Our next example will be one where there are three variables. So we want to find the minimum cost of an open rectangular box with a volume of 24 feet cubed. And the materials for the box are going to be $1 per square foot for the front and back, $2 per square foot for the bottom, and $3 per square foot for the other two sides. So first, we just need to figure out what is the cost of constructing this box as a function of x, y, and z. So it's $1 per square foot for the front and the back. And the area of the front and the back is going to be y times z. So if we're going to do $1 per square foot times yz, that would give us the front, but we also need the back, so we're going to need two of those. Okay, so that's the front and the back. Now, we want to add $2 per square foot for the bottom. The bottom is going to be x times y for the area, and then $2 per square foot times that area. So that 2 is just for the bottom. So this one is the bottom. That's the front and back. And then finally, we're going to do $3 per square foot for the other two sides. The other two sides are going to be x times z. And it should be $3 per square foot times that area. But since we have two of those sides, we will have 6xz. And that is the function that we're going to try to minimize cost. The constraint for this problem is going to be the volume, x times y times z, and that is supposed to be 24. So now that we have our function that we want to maximize or minimize, this one right there, and we have our constraint, okay, now we can set up a Lagrange multipliers problem. So we're going to look at the derivative of c with respect to x, which the first term is going to be 0, the second term is going to be 2y, and the third term is going to be 6z. The derivative of c with respect to y, the first derivative is going to be 2z, the second one is going to be 2x, and the third term is 0. And the derivative of c with respect to z, and that's going to be 2y. The derivative of the second term is going to be 0, and the derivative of the third term is going to be 6x. Now, dg dx, the derivative of the constraint is going to be yz. dg dy, that derivative is going to be xz. And dg dz, that derivative is going to be xy. And so what that does is that gives us three Lagrange multipliers equations. We have that 2y plus 6z is going to equal lambda yz. 2z plus 2x is going to equal lambda xz. And 2y plus 6x is going to equal lambda xy. Now to solve these problems, we're still going to use the same process that we used before. So my suggestion is always to solve for lambda, to come up with three equations here. Okay, the first one, if we solve for lambda, is that 2y plus 6z over yz equals lambda. The second one is that 2z plus 2x over xz is equal to lambda. And the third is that 2y plus 6x over xy is equal to lambda. We may want to rewrite these to make them a little bit easier to deal with. Okay, so 2y over yz is going to be 2 over z plus 6z over yz is going to be 6 over y. That'll equal lambda. If we divide both terms by xz, we'll get 2 over x plus 2 over z is equal to lambda. And then finally, dividing by xy, both terms, we get 2 over x plus 6 over y is equal to lambda. Okay, so those are 3 equations, but we have 4 unknowns, x, y, z, and lambda. So we remember that our constraint is going to be our 4th equation. Okay, to solve this, we're going to want to set 1 equal to 2. So that 2 over z plus 6 over y is equal to 2 over x plus 2 over z. We'll notice that the 2 over z's cancel, which is nice because they're on both sides. So then if we cross multiply, we see that 6x equals 2y. Okay, that's going to tell me that y equals 3x. Let's set 1 and 3 equal to each other now. What do we get? Well, 2 over z plus 6 over y is now going to equal 2 over x plus 6 over y. Now 6 over y appears on both the left and the right, so we're going to cancel those. And we're going to be left with cross multiplying 2x equals 2z, or z equals x. So now we know that y equals 3x and z equals x, so we can put those 2 things into our 4th equation. Okay, I will rewrite the equation that x, y, z equals 24. And so here we see that x times 3x times x is equal to 24. If I divide by 3, I have x cubed is equal to 8. So x is equal to 2. So now I see that x is 2 feet, y is 6 feet, z is 2 feet, and the cost of doing a 2 by 6 by 2 box is going to be 2 times 6 times 2 plus 2 times 2 times 6 plus 6 times 2 times 2, which equals $72. And that completes our first problem with 3 variables, x, y, and z.